The topic of this video is long multiplication. I'd like to show you a clever way of doing it. The method is easy to do, it's easy to check, and best of all, it's easy to understand in terms of place value and the distributive law. This is nice because it makes it easier to remember, and as a side benefit, it deepens your understanding of the fundamental principles involved. This is the first of two videos. In this video, we're going to concentrate on the principles involved, and we're also going to do some simple examples. In a later video, we'll generalize to the general case so you can multiply anything by anything. I assume you already know what the distributive law is, and I assume you know what place value means. You also need to know your multiplication facts up to 9 by 9, short multiplication. This needs to be reliable, but it doesn't need to be fast, so take your time. It's more important to be reliable than fast. Also, at this stage, you don't even need to have your times tables committed to memory. I don't care if you have to write out times tables. Do whatever you have to do so that your short multiplication is reliable. It'll get faster over time. It'll solidify in your memory over time. In fact, long multiplication gives you plenty of practice doing short multiplication, so we can kill two birds with one stone. Let's do a couple of simple examples. Let's start by multiplying 432 by 1. That's pretty easy. You can do that in your head. So let's just write this down. 432 times 1 is 432. Slightly more interesting examples, let's multiply 432 by 2. You can also do that in your head. In particular, you can do it multiplying digit by digit, which is an important concept. So let's do this digit by digit. So we're going to have 8, 6, 4. So the answer is 864. As an even more interesting example, let's multiply 432 by 20. That's almost as easy because multiplying by 20 is the same as multiplying by 2 and then shifting over one place. So let's do that. I have a 0, and then we're going to have a 4, and 6, and an 8. So the answer is 8,640. For our next example, let's multiply by 21. 432 by 21. We can help ourselves if we expand 21 and write it as 20 plus 1. That comes directly from the number system. That's what 21 means. Therefore, 432 times 21 is equal to 432 times 20 plus 1. And there's two ways of understanding where that comes from. First of all, you can just say that we've taken the previous equation and multiplied both sides by 432. Another way of saying it is we start with the right-hand side here, and we have this 21, and we replace the 21 by something it's equal to, because that's equal. So we're just going to do substitution here. That's the second way of understanding where that comes from. So now we get to use the distributive law. This thing here, we can write that out as 432 times 20 plus 432 times 1. And that has the advantage that we know both of those numbers. We just did them on the previous slide. So we can write that out. That's going to be 8640 plus 432. So you're beginning to see the strategy here is that we proceed digit by digit. And also, as a general rule, long multiplication is just a bunch of short multiplication plus one big addition. So what we've done here is we started out with a multiplication problem here, and we managed to turn it into an addition problem. Let's redo the same problem we did in the last slide, except that rather than formatting it as a series of equations, let's format it in a way that is more compact, more convenient, and more systematic. We know from the previous slide that we can write 21 as 20 plus 1. 1 times 432 is 432 32, which we can write there. And 20 times 432 is 8,640, which we can write there. Now all we need to do is add those guys up. This is an addition problem now. 2 plus 0 is 2, which we put there. 3 plus 4 is 7. 4 plus 6 is 10. Carry the 1, gives us a 9. And that's the right answer. That's 432 times 21. Before we go on, I'd like to call your attention to this guy. Normally, when you write a number like 8,640, you have to write the 0, otherwise it wouldn't have the right place value. But we've got something special going on here. We've got everything lined up in columns. You don't actually need to write that. If you leave that out and do the addition, you get the same answer. So you can either write that or not write that. Either way, as long as you got things lined up in columns, you get the right answer. The columns are keeping track of place value for us. There's a trade-off here. By accepting the requirement to keep things lined up in columns, we free ourselves from the requirement to write a whole bunch of zeros. We use this freedom to make long multiplication more efficient and more convenient. Let's do another long multiplication problem. This time we're going to organize it as long multiplication using systematic method. So the method starts by picking apart the second factor here, picking apart individual digits. And then we start with the rightmost digit here, the low order digit, and multiply that into the other factor digit by digit. So 1 times 2 is 2, put that there, and 1 times 3 is a 3, so put that there, 1 times 4 is 4. Now we move on to the second digit. We do the same thing, only shifted over 1. So 1 times 2 is 2, shifted over so it lines up under this digit, and then times 3, then 1 times 4. Now we go on to the third digit, and we multiply into that thing digit by digit, but it'll be lined up under the 2 here. So this is going to give us a 4 and a 6 and an 8. Now all we have to do is add those guys up, and that gives us 2, 5, 11, carry the 1, makes 1, carry the 1, makes 9. So let's emphasize a couple of points here. First of all, it's really important to keep things lined up in columns. And graph paper helps with this. Actually, the ideal thing is a lab notebook, which is a bound book where every page is graph paper. That keeps everything all in one place. Another little thing here is you'll notice that every other number here I've written on odd half of a line here. I'm skipping a line and a half each time here. And the point is that the graph paper is supposed to help you. It's not supposed to constrain you. If the vertical lines are helping, use the vertical lines. If the horizontal lines are not helping, skip a line and a half each time. You've got plenty of people in this world trying to make you color inside the lines. I'm here to tell you that sometimes it helps to color outside the lines. So we did this problem once in terms of just the method. Pick this apart, do this, line up that. Well, it's all very mechanical. But I'd like to point out that everything we did here is well justified in terms of the distributive law and the axioms of the Hindu numeral system here. So in particular, this is 432 times 1. This is 432 times 10 with an implicit 0 here. This is 432 times 200 with a couple of implicit zeros here, and we're using the columns to take care of the place value. So at one level, it's just a mechanical algorithm that you can do without thinking, but at another level, it's entirely well-founded in terms of the axioms of arithmetic. At this point, you've seen all the basic ideas needed for long multiplication, with one slight limitation. So far, every time we've done a short multiplication problem, the product has been a single digit, such as 2 times 3 is a single digit, 2 times 4 is a single digit. In the next video, we'll see how to handle multi-digit products, such as 3 times 5 is 2 digits. At that point, we'll have achieved an important goal. We will have a completely general algorithm. You'll be able to multiply any integer by any integer.